Okay, we've already worked 1. We've worked 2, where you set each factor equal to 0. And because this one had exponent of 3, it had a multiplicity of 3. This one had an exponent of 1, multiplicity of 1, 1, multiplicity of 1. This one, we're going to end up with positive 2 and negative 2, each with a multiplicity of 1. So that number 2 answer is A. Number 3's work the same way. Let's skip down and do number 4. Number 4 says, write a polynomial in complete factored form that satisfies the conditions. Let the leading coefficient be 1. It's degree 5. It has zeros -7 with a multiplicity of 4. Okay. If x is equal to -7, that's the final statement. We're going to work our way back up. If x was -7, then this said x plus 7 equals 0. So we had x plus 7 as a factor. It has a multiplicity of 4, so it has an exponent of 4. 9. If x equals 9, then right before that you probably had x minus 9 equals 0. So that factor is x minus 9 with a multiplicity of 1. 4 and 1 make that a degree 5. So number 4, answer choice is C. Question 5. It says if R is a 0 of even multiplicity, then the graph is going to turn around. This is what they're talking about. There's going to be a turn. If R is of odd multiplicity, then it's going to cross. So it's going to be something like this. So those are your answer choices for number 5. Question 6. The graph of this polynomial is shown. Estimate the zeros and state whether their multiplicities are odd or even. Well, the first one I see is at -4, and it just crosses, so that means it's odd. The next one is at 3, and it turns around, so it is even. Things to note about number 7. It opens down, which causes it to have a negative. It has a 0 at -4, and it turns around, so it has an even multiplicity. And has a 0 at 3. It turns around, so it has an even multiplicity. So when we find our zeros and we work our way backwards, we see that our factors are x plus 4 squared and x minus 3 squared. Number 8, this function has this graph. They want you to write the factored form. So I have a 0 at -7. If x equals -7, then I'll work my way back, and I had x plus 7 as a factor. Because it turned around, it's degree 2. 0, x equals 0, means that I have a factor of simply x. It crosses, so that has a multiplicity of 1. X equals 7 has a factor of x minus 7, and it has a multiplicity of 1 because it simply crosses. So degree 2 plus 1 is degree 4, which is what I'm supposed to end up with. Number 9, I have a 0 at -4, so x equals -4. So when I work my way backwards, my factor was x plus 4. I also have a 0 at 4. Work my way backwards, and it's -4, x minus 4. I have a 0 at 6. Work my way backwards, and I have x minus 6. Number 10, choose the correct function. You could put it in your calculator, but you see that you have a 0 at -1. So x equals -1 means the factor is x plus 1. It just crosses, so it's of odd. And x equals 3 turns around, so it's going to be even. So that's our x plus 1. And then x minus 3 squared. So that's answer choice B. 11, find a polynomial of the least possible degree having the graph shown. We have a 0 at -6. So x equals -6 means when I work backwards, I had x plus 6 as a factor. I have a 0 at 3, so that gives me x minus 3 as a factor, and I have a 0 at 5, which gives me x minus 5 as a factor. Now, the y-intercept is 45. The y-intercept is the constant, and that would be what I would get when I multiplied 6 times negative 3 times negative 5. But when I multiply those, I get 90. Well, 45 is half of 90, so it must have a multiplier of 1/2. So I have these factors, and I need 1/2, and that is answer choice A. 12 is the same as 11. 13 is actually the same too. You have a 0 at negative 5, so your factor is x plus 5. You have another 0 at 3, so your factor is x minus 3. It turns here, so that's degree 2. If you multiply 5 times negative 3 times negative 3, you're going to get 45. But your y-intercept is 9, so it is 1/5 of that. So my function is 1/5 times x to the 5th times x minus 3 squared. Okay, question 14. List all the possible rational zeros. Well, here's what you need to do. You need to list all the possible factors of the constant 27, which it could be plus or minus 1 times plus or minus 27, plus or minus 3 times plus or minus 9. Then list all the possible factors of the leading coefficient, which is 3, plus or minus 1, plus or minus 3. Now make all the possible ratios of C over LC factors. So it could be 1 over 1, or positive or negative 1 over 1, positive or negative 1 over 3. Then you use 27 over 1, 27 over 3, 3 over 1, 3 over 3, 9 over 1, 9 over 3. So there's my list. Now I go through and I say, okay, this is 1, this is 1/3, this is 27, this is 9, this is 1. I've already used it, so I don't have to repeat it. This is 3, this is 9, which is already here, this is 3, which is already here. So these are the numbers I'm looking for, and that's answer choice A. You will do the same for 15 and 16. Then 16 asks you to find which ones actually work. So I want you to take your calculator, and we're going to put that function in our calculator. It is x to the 3rd plus 13x squared plus 47x plus 35. And there's your graph. You can see that there's 3. 1 looks like it's at negative 1. Okay, so I'm going to go to the table, and I'm going to scroll around and look at these values. You know what I'm looking for? I'm looking for these zeros. I see one at negative 7. I see one at negative 5. I see one at negative 1. This problem, you could get all that you needed from the table, so that answer choice is C. You're going to do the same thing on 17 with the constant over the leading coefficient, and you're going to collect all your fractions here, and then you're going to put it in your calculator. This one says 10x to the 3rd minus 67x squared plus 113x minus 20. We're going to graph it. We're going to go to the table, and I'm looking for zeros here. I see 1 at 4. Okay, 4 works. Now, you can synthetically divide by 4 and then use the quadratic formula, or multiple choice, you could plug these in and see which ones work. So if it's going to work, you're going to be able to use it in this equation. 10 times 1/5 to the 3rd minus 67 times 1/5 squared plus 113 times 1/5 minus 20. And when you plug it in, you're going to get 0. So we know 1/5 works. And you can do the same thing with 5 over 2, and it'll work as well. 18 is the same as the previous two. It's going to take a little time. And it will, you can use your calculator to find that. 19, this statement is true because you know you have your conjugates. Number 20. Question 20. They want you to factor it into linear factors given that k is equal to 3 is a factor. So 3 here, and we're going to synthetically divide. We got 2, 5, negative 73, and 120. 2 times 3 is 6. That makes 11. It's 33, negative 40, negative 120. No. So this is 2x squared plus 11x minus 40, a, b, and c. And we're going to use the quadratic formula. It says negative b plus or minus b squared minus 4ac all over 2a. So negative 11 plus or minus the square root of 11 squared minus 4 times 2 times negative 40 all over 2 times 2. So that's going to give me negative 11 plus or minus the square root of 441 over 4. The answer to the square root of 441 is 21. So it's negative 11 plus or minus 21 over 4. Negative 11 minus 21 over 4. Negative 32 over 4. Negative 8. Negative 11 plus 21 over 4 is 10 over 4, which is 5 over 2. Now, let me show you what we're going to do with those. X could be 3 from up there, so that meant that the factor would have been x minus 3. X could be negative 8, which means that you would have had x plus 8. X could be 5 over 2, which would mean x minus 5 over 2 in parentheses. Now let's talk about this one. We're not going to leave it like that. We don't want this to be a fraction. So I'm going to multiply both parts of this by 2 so that I get that out of a fraction. So those are your 3 factors.